Alright, y'all, let's get this thing started. Today we're going to be talking about Saturn's hexagon. Ever since its discovery, the hexagon has been a puzzle for planetary scientists all around the globe. The hexagonal cloud pattern was actually first discovered in 1988 by scientists who were reviewing data from NASA's Voyager flybys of Saturn that happened in the early 80s. However, its existence wasn't exactly confirmed until NASA's Cassini spacecraft observed the ring planet really up close years later in 2006. Guess how big it is?
That's what she said.
That's my joke. Damn it, Dwight.
The hexagon structure is oddly symmetrical. It's about 18,000 miles wide, with each of the sides being around 9,000 miles long, and it reaches up to about 190 miles high into Saturn's atmosphere. Basically, two Earths can fit inside the hexagon with room to spare. It's also made up with an atmospheric jet stream with winds that blow up to 200 miles per hour. Within the hexagon, scientists have observed a wide variety of hurricane-like structures, and in this image you'll see a massive hurricane that is tightly centered on the North Pole, with an eye that's 50 times larger than the average hurricane eye on Earth. There are numerous smaller hurricanes which appear to be reddish ovals. The largest of them, though, is the whitish oval in the right corner, that ranges about 2,200 miles long, approximately twice the size of the largest hurricane ever recorded on Earth.
Whoa! Hurricane Katrina! More like Hurricane Tortilla.
During the earlier stages of the Cassini mission, the hexagon was a light baby blue color, but as the prolonged investigation went on into the hexagon, the color changed from blue to gold and somewhat yellow. Nothing like the hexagon has ever been seen on any other planet discovered by scientists, so of course multiple hypotheses have been made to explain the hexagonal cloud pattern and how or why it developed. In order to try and understand as to how or why Saturn's North Pole has a hexagon, scientists tried to recreate its cloud pattern in their lab. After a while of relentlessly testing multiple different hypotheses, the best one came when they set up a cylinder-like rotatable tank that had a lid and base that were split into sections. They could rotate the inner circle at a different rate than they rotated the outer circle, setting up a gradient in the flow speed. So within Saturn's hexagon, it's not really the speeds that are important, but more so the gradient within those wind speeds. Where there are steep contrasts within them, you can induce unstable behavior in a fluid, including waves, eddies, or swirls, thus creating Saturn's hexagonal cloud pattern.
It's alive! Oh, it's alive! It's alive! It's alive!
I can't sleep because of that video.
Thanks to the Cassini spacecraft, scientists have been able to discover the hexagonal mystery of Saturn's North Pole. It was able to deliver new insights and up-close images that allowed scientists the ability to understand the cloud pattern. Sadly, the robotic spacecraft only discovered Saturn's hexagon right before the end of its lifespan. It was launched October 15th of 1997 and was adrift in space many years until it finally reached Saturn, with its final mission ending not too long ago on September 15th of 2017.
The arms of the angel fly away.
Rest in peace, little buddy. You did good. Alright, well, I hope you guys learned something here, because at this point, I pretty much know more about Saturn's hexagon than I do myself, so I'ma head out.